welcome back to my channel. In the last video, we have discussed about introduction about Fourier series and Fourier expansion. Now we'll move on to the problematic section. We'll solve one problem based on Fourier series. Before that, the very important thing you should know is integration formula. So it is the prerequisite for the Fourier series. So I'll just give few formulae. Please note it down. Very important formulae. So that is integral e power ax cos bx into dx. That is equal to. Why this formula is used? Because using integration by parts, we cannot solve this kind of problems. Because e power ax also infinite series, cos bx also infinite series. If we integrate or differentiate n number of times both the terms, they will not vanish. So that we'll use standard formula in integration, that is e power ax cos bx. So e power ax divided by a square plus b square a cos bx plus b sin bx. This is very important formula when we have the product of e power ax into cos bx dx. Similarly, one more formula, e power x into sin bx dx. So what it says, e power x divided by a square plus b square a sin bx minus b cos bx. This is another important formula which is used to integrate terms like this. Okay. Now these two are very important. Along with this, we should know also some trigonometric terms. So what is that? Sin n pi, we should know sin n pi is 0. Similarly, cos n pi is what? Minus 1 power n. In particular, if I take even multiples of n, so that is cos 2n pi is plus 1 and cos 2n plus 1 into pi, that is odd multiple of n value is what? Minus 1. If we know all these things, then Fourier series concept is somehow easy, because the Fourier series is nothing but completely integration. Now I'll move on to one simple problem in Fourier series. We'll solve that. Very simple, as I told, there is no much difficulties. To take one problem, that is obtain Fourier series expansion for the function f of x equal to pi minus x by 2 in the interval 0 to 2 pi. Also deduce that 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 etc. that is equal to pi by 4. This we are supposed to solve. Now I am going to solve this problem by direct method. As why I am using the word direct means, because in Fourier series we have alternate method also, that is by using the even odd concept. If we know the function is even, then we can directly write bn value as 0. If we know the function is odd, then we can directly write a naught n will be 0. But I am not using that. I am going with direct method so that you can understand it properly. Okay. So the Fourier series, our standard form is nothing but f of x equal to what it says, a naught by 2 summation n equal to 1 to infinity a n cos n phi x by l plus summation n equal to 1 to infinity b n sin n phi x by l. This is the standard form of the Fourier series with arbitrary period. Now there are two types of standard arbitrary period, that is minus L to plus L and 0 to 2n. These are the two standard forms. On comparison, the given limit is of the form 0 to 2l, this form. Therefore, we can easily find out L value. So, in place of 2l, we have 2 pi. 2l equal to 2 pi. That means L equal to pi. L equal to pi. So, I will rewrite the above Fourier series for this L value. So, what happens? F of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n pi, and this L value is also pi. Pi will cancel. It is nx plus summation n equal to 1 to infinity bn sin nx. This is the standard form of the Fourier series for the given problem. Now, here a0, an, bn, these are all Fourier coefficients, and we have to find out these Fourier coefficients by using the Euler's formula. I hope you got this one. Okay. Now I will move on to a0, an, bn value. So I just I will move on to a0. How to find out a0? We will move on to how to find out an and bn. Now, first time a0. Formula says 1 by L. What is L value? L value is pi. Integral 0 to 2 pi, because the given limit is 0 to 2 pi. F of x into dx, that is equal to 1 by pi integral 0 to 2 pi. What is f of x value? F of x is pi minus x divided by 2 into dx. So that is equal to 1 by 2 constant free term, take it outside, that is 2 pi. We left with pi minus x. Integration of pi with respect to x is x. Integration of x with respect to x is x square by 2 between the limit 0 to 2 pi. So now what happens? 1 by 2 pi. If I operate upper limit, x value is 2 pi. Pi into 2 pi, so it becomes 2 pi square minus, here 2 pi whole square means 4 pi square by 2, again it is 2 pi square. Upper limit I will substitute for whole term, so minus lower limit for whole term. X value is 0, 0 into something 0, minus 0, therefore 2 pi square minus 2 pi square 0, so a0 value will be 0. Very simple, my dear students. So here you should know how to operate the limits also. That is very, very important in definite integration. Okay. So we got a0 value as 0. Then we will move on to an value. So how to find out an equal to 1 by pi integral 0 to 2 pi f of x cos nx into dx. This is an value, that is an equal to 1 by pi integral 0 to pi 2 pi f of x is what? Pi minus x by 2 cos nx dx. Now we know integration by parts standard rule, that is Bernoulli's rule, u into v dx, that is equal to u integral v dx minus u dash double integral v dx plus or minus etc. We have to apply that formula for this particular problem. Here this is u, this is v. So what happens? An equal to 1 by pi integral 0 to pi. This is u. First term I will integrate. So I will remove this integration sign. I am applying that formula, Bernoulli's rule or general integration by parts. First term pi minus x by 2 into integral of cos nx dx minus differentiation of first term pi 0, so minus 1 by 2, because 1 by 2 constant, pi differentiation 0, minus x differentiation minus 1. Therefore it is minus 1 by 2 into double integral of cos nx dx into dx. Now this is, if I simplify 1 by pi minus x by 2 cos nx integration is what? Sin nx divided by n minus into minus plus. One time integration we got here. Since double integration means we have to integrate this one more time. So sin integration is what? Minus cos. So what we have? 1 by 2 into minus cos nx divided by n square between the limit 0 to 2 pi. So whenever we have sine term with the limit 0 to pi or minus pi to pi, we can directly write this limit term as 0. Why? Because if I replace 2 pi here, it becomes sine 2 n pi. Sine 2 n pi is 0. Similarly, substitute x equal to 0, that is also 0. So no need to simplify by substituting the limits, it is unrestricted. And you can easily understand this. Okay. Now, the remaining term is this. So what happens? 1 by pi, I take this 2n square outside because there are free terms and constant. Minus also I take outside. So what happens? It is 2n square into pi. Remaining term is cos nx between the limit 0 to 2 pi. So minus 1 by 2n square pi. Upper limit is cos 2n pi. Cos 2n pi is even. So it becomes 1. Cos 0 is also 1. 1 minus 1 0. 0 into something 0. Therefore an value is also what? 0. So a0 is also 0, an is also 0 for this particular problem. Then we will move on to bn value. Okay. Same method, integration by parts only we have to apply, we have to simplify. Very simple concept. Now bn value, so what it says, 1 by pi integral 0 to 2 pi f of x. What is f of x? Pi minus x divided by 2 into sin nx dx. So what happens if I integrate this by parts method? 1 by 2, first term as it is, pi minus x by 2, integration of sin nx dx minus differentiation of this 1 by 2 constant. I write 1 by 2 constant. Pi differentiation 0 minus x differentiation is what? Minus 1. So double integration of sin nx dx between the limits 0 to 2 pi. So what happens it is 1 by 2 pi minus x by 2 integral of sin is what? Minus cos nx divided by n minus into minus plus. One time integral of sin is minus cos integration, again you have to integrate plus sign, plus into minus. So it becomes sin nx divided by n square. I hope you got this. Sin one time integration minus cos nx by n. If I integrate this one more time, minus as it is, cos integration is sin nx divided by n. 1n is already there, so n square. This minus and this minus become plus, but 1 by 2, I will keep it as it is. Between the limit 0 to 2 pi. Between the limit 0 to 2 pi. This is over, minus into minus plus, 1 by 2 over, its integration is minus sin nx by n square. As again, this term is going to be 0 because sin n pi is 0, sin 0 is 0. Therefore, we left with what? 1 by this I will bring outside, 2 into 2 4n, I will take it outside, minus also I will write outside, remaining term is pi minus x into cos nx between the limit 0 to 2 pi. So what happens now? This we have to simplify further. So that is bn equal to minus 1 by 4n, because minus 1 by 2 into 2 n minus 1 by 4n. Upper limit is what? 2 pi. If I replace in place of x, pi minus 2 pi minus pi, I am operating upper limit for the entire function. Cos n pi, upper limit for the entire function. Pi minus 2 pi into cos 2 n pi. because x value is 2, so I forgot to write 2 here, 2n pi minus lower limit. So what happens minus lower limit? 0, pi minus 0 is what? Pi, and this is what? Cos 0. Cos 0 is what? 1. So now if I simplify this, Bn equal to minus 1 by 4n minus pi cos 2n pi. Cos 2n pi is what? 1. 1, again this is minus pi. So what happens? Bn equal to minus 2 pi minus into minus plus 2 pi divided by 4n. 2 pi divided by 4n. I hope it is clear, guys. Now, I think I forgotten this 1 by pi. Instead of 1 by pi, I have written this 1 by 2. Sorry, this is 1 by pi, not 1 by 2. This is also 1 by pi. So 1 by pi means, so it becomes 2 pi n. 2 pi n, because sorry, this is 1 by pi. I have written 2 here. So 1 by pi, 2 n pi. So now what happens here also? This is minus 1 by 2 pi n, pi minus x. This is 2 pi n. So this is also 2 pi n. This is also 2 pi n. 2 pi cancel. Bn equal to 1 by n. So very simple, okay. But be careful while handling the steps, because if we forget one sign or one term, see, just I forgotten, instead of writing pi, I have written 2. The entire answer might be wrong. Okay, so please be careful. So now Bn equal to 1 by n. So now we got A0 value, we got An value, we got Bn value. We have to construct the required Fourier series. So what is the required Fourier series? Fourier series f of x equal to A0 by 2. Since A0 is 0, no need to write. Then summation n equal to 1 to infinity an into cos nx. An is also 0, no need to write. So we have only Bn term. N equal to 1 to infinity. What is Bn value we got? 1 by n sin nx. So this is our required Fourier series. From this Fourier series, we have to deduce the required result. Whatever they have given, that required result. So this is our Fourier series for the function what? Pi minus x by 2. And see, whenever you are deducing the result, you should know what is right hand side value. Right hand side value is sine. Sine has value only for 90, right? Sine 90 is 1. For all again, standard angle sine 0, sine 180, sine like that it will become 0. So sine 90 is what? 1. So the only option to take here x equal to pi by 2. Let x equal to pi by 2. When I take x equal to pi by 2, I have to substitute left hand side also. Pi minus pi by 2 divided by 2, that is equal to summation n equal to 1 to infinity 1 by n. So what happens it is sin n x value is what? Pi by 2. So it is LCM if I take 2 pi minus pi by 4. That is equal to, if you keep on substituting the n values here, sin n equal to 1, sin 90 minus 1. If you take n equal to 2, so it becomes 2 to sin by 0, n equal to 3, 1 by 3, again it is 1. So like that it will continue. So that is the required series for the given problem. So I hope it is very simple and you can you can do it. Okay. So I hope you enjoyed this. So thank you all. We'll meet with the next problem. So we'll meet in the next video. Thank you all.